thank you so much for joining us today for the third episode of our business webinar series. We have a very exciting topic for you today, which is communications, as strong as the carrier behind it. Since you count on the connectivity, reliability, and feature sets of not only the platform you're using, but also the strength of your carrier, this webinar will focus on some of the best practices around carrier infrastructure, control, and software interfaces to help empower you to get more out of your carriers. Today, leading the conversation will be McLean Roth. He is the sales director of our long-term partner Telnyx, a real-time communications provider in Chicago, and we're happy to have him join us today. McLean has been in the telecommunications industry for years now and started off as a sales engineer and tech consultant with AT&T before shifting into his role at Telnyx. McLean has a roughly 30-minute presentation for you today, so we have plenty of time for questions during and after the webinar. Please submit questions in the questions section of your GoToWebinar screen, and if you have a timely question on the content being discussed, feel free to submit it and raise your hand during the presentation. I'll be keeping an eye out for them as we go along. Again, thank you so much for joining us, and if you have topics you'd like us to cover or people you'd like to hear from, send an email to marketing@2600hz.com and we'll see what we can do. All right, McLean, take it away.
Thank you, Lisa, and thank everybody for joining. Pleasure being here. As she just mentioned, I've always found webinars to be interesting in that I am presenting to my own screen, and it's hard to gauge whether or not people are enjoying or interested in something more than the other. So please, by all means, raise your hand. If there's something in particular, I would love to cater the conversation and make this more of a conversation. So with that being said, why don't we go ahead and get things started? So as Lisa mentioned, I am the director of sales at Telnyx, and I do have my background originally coming from the AT&T world. I was a technical sales consultant there, and I spent a lot of my time in investigating kind of architecting solutions, many of which touched on this telecommunications, specifically voice over IP and delivering things in the dial tone space. At my time there, I found myself more and more interested in going deeper rather than broader across the telecom sphere. And what ended up happening is I had the pleasure of running into the Telnyx team over the course of my work and kind of fell in love with the idea of learning more about what a carrier really is, how we as a carrier empower and become a dependency for communications platforms like contact center solutions, like hosted phone systems, like Kazoo from 2600 Hertz. And so I've had the wonderful pleasure of being at Telnyx for almost 3.5 years now, and for much of that time working with 2600 Hertz. So it's really exciting that we're finally able to put together a webinar together. So without further ado, let's dive into the topic here. So today, as Lisa mentioned, the topic is only as strong as the carrier behind it in reference to communications. And what I'm really trying to get at here is there is this concept of voice over IP, and in my opinion, a lot of it is under the hood. What I mean by that is the end user, and in many cases, even the service provider, really doesn't have a lot of insight or transparency into what's going on from the time that they send the call out to their provider or their carrier, et cetera, and anything that goes beyond that call it veil. And so today what I kind of want to do is talk a little bit about what a carrier is, what their primary role is, that is connecting phone calls and getting you to the PSTN, and then kind of talk about some of the implications of working with a carrier versus maybe an intermediary or an aggregator or a provider of sorts. And hopefully at the end of the conversation, we can all be a little bit more informed and a little bit more knowledgeable when it comes to assessing what you should be getting from your carrier and what limitations you have by selecting a carrier, et cetera. So as mentioned, please feel free to raise your hand and ping me with questions throughout the conversation. Would love to have as much back and forth as possible. So to start with, I think we need to agree on what is a carrier. This kind of reminds me of some of the early conversations I had in my telecom experience being, hey, my customer asked me, what's a tier 1? Like, why is their current provider a tier 2? And I think that is a great analogy here, because there's a lot of ambiguity between, is my provider actually a reseller? Are they actually a carrier? Are they a provider? What do these terms even mean? And so, excuse my lame diagrams here, but I like to use this internet service provider analogy. So if you've ever seen a diagram that looks like this, there's this concept, and clearly written, I think formally, a tier 1 network is like an IP network that can reach the rest of the internet solely via what's called public peering. In other words, they're not paying for access to any parts of the internet. And then a tier 2 would be someone who works with tier 1s to access the rest of the internet, et cetera, and down the chain. And I think this is actually a nice analogy. So if you, instead of using ISP terms, let's go to this idea. Imagine if the PSTN, that public switch telephone network, is the tier 1. And the idea is, what makes you a carrier is having direct access to PSTN. In other words, you don't need somebody else to get you to the phone network and some of the assets that are on the phone network that are owned and operated by operators, by carriers. Now, this is a nice diagram to kind of provide a framework for understanding what a carrier is, but there are a couple of things that I want to just knock out as actual requirements for you to see someone as a carrier, at least as I view a carrier. And I've given some conversations, I've had some talks about this in more detail, but here are the 3 main things I like to think about: numbers, what type of partnerships they have access to, and what sort of privilege they have from the regulating body. And so when we're talking about numbers, we're talking about, hey, if I look up this phone number in the switch database in this LERG, what am I going to see? Well, hopefully you're going to see the operating carrier number, that OCN and SPID of the carrier. Oftentimes you'll realize that if you look up a number that you have with your provider, it's actually not going to show their name. It'll show some subsidiary provider that actually is under them. And in many cases, you might look up an AT&T number and find out that they still operate with God knows how many OCNs across all of the mob bells that used to exist. And so when I think of a carrier, they need to own their own numbers, and they need to be able to put those numbers directly on the tandems of the PSTN. And then furthermore, NANPA, that's the North American Number Planning Association. So I think of a carrier as someone who works directly with NANPA to procure their own numbering. When it comes to partners, we're really talking about 2 major things here. Do you have direct connects to the PSTN? In other words, are you terminating directly to the actual local exchange carriers that live on the PSTN? Or are you terminating to some middleman, some aggregator, some reseller that will in turn connect you to the tier 1, or in this case, the actual carrier? So by being a carrier, you should be directly connected with other carriers. Similarly, you should have the ability to do some of this internetworking. And so when I'm talking about internetworking, I'm usually referring to CSRs, but there are other pools and databases like the LRN, et cetera, that you really only can access if you're a carrier. And so that's kind of important in my mind to being a carrier. It's something to consider if you're evaluating whether or not your provider is a carrier or a reseller or an aggregator, if you're trying to determine that. And then last but certainly not least is this regulatory privilege. So we're all probably familiar with this term CLEC, competitive local exchange carrier. It used to be the case that if you wanted to become a carrier, you had to become a CLEC. In other words, you had to go lease equipment from one of the existing local exchange carriers, usually an AT&T or a Verizon. What has happened in the recent years is we've been slowly but surely moving away from the copper PSTN and trying to leverage the internet and some of these more fiber-based networks to deliver communications. As a result, the FCC had a ruling, I believe 1570, that opened up a new category so that you could become a licensed carrier operator without having to go the CLEC route. It's just a number of certifications that are required to establish your connectivity to the PSTN, to establish your maintenance of your network, your high availability, et cetera. And with this regulatory privilege comes some access to systems that you wouldn't otherwise have. One of this being NPAC, the Number Portability Administration Center. I believe I said that correctly. And that's where you do all of your porting and activation of numbers. So these are like crucial systems. And if your carrier really doesn't have access to them, I would say that maybe you're really working with a reseller, with an aggregator of sorts, some sort of intermediary that in turn references their relationships with other carriers. And so hopefully this provides at least somewhat of an agreed upon understanding of when I say carrier, this is what I'm referring to. And when I say reseller or aggregator, I mean someone who works with carriers and aggregates all of those different options, and then in turn resells that dial tone to providers, end users, etc. And so with that being said, I think the next thing I really want to talk about is kind of what is your carrier primarily responsible for? Well, they're responsible for, in our world, delivering this voice over IP. And so the question becomes, what is voice over IP? How does it work? And we're going to talk about this at a very high level. I'm sure some of us have more or less familiarity with diving into SIP. And so today I just kind of want to talk high level and make sure that there are some key components that you can use to understand the limitations or the empowerment that's coming from your carrier. So for starters, there's this idea of session initiation protocol, SIP. Here is the formalized definition that I find that kind of maps to what I usually see. I personally like to think of it very simply. It allows us to perform all of the traditional functions of the PSTN, but using the internet as a medium instead. So for those of you who maybe have spent more time with legacy infrastructure, you might be more familiar with the PSTN language, this SS7. What I think of SIP, SS7 is to the PSTN what SIP is to the internet. They both allow for communicating and establishing calls. So this is like ringing phones, initiating a phone call, like answering a phone call, establishing codecs, putting calls on hold. Hey, there's a busy tone on this call. The number's out of service. All of these functions, these workflows, these processes are determined and exchanged between carriers on the PSTN using SS7. And so session initiation protocol is what was invented, designed to take all of that functionality and bring it to the internet. So to kind of give some people an understanding of what that might look like, I'm going to walk through, again, super high level, but a little bit deeper of a dive into call flow. So what does a call look like? And so what I'm looking at here is on the left, we have, imagine the PSTN. In the middle, we have some sort of intermediary that's doing the exchange, whether it be the carrier or whether it be just a device that's going to exchange us from SS7 here to SIP here. And so if you guys have seen a SIP ladder before, you've probably seen something that looks like this. So in the traditional world, when a phone call is established, they use this thing called an IM, which is an initial address message. It's basically saying, hey, I'm trying to call somebody. In the SIP world, we turn that into an invite, and we send a SIP invite to the destination that's trying to receive the call. In order to ring that phone call, that end device using SIP is going to respond saying like, hey, I'm trying to connect to this end device. And then they're going to say, hey, I've connected to the end device. I'm ringing the phone. That will get translated back to SS7 as address complete message. You'll notice that there's some nuanced differences here, i.e. that in the internet world, right, we're responding multiple times to one response in SS7. And part of this is in the design of SIP and allows for us to do things like acknowledge the fact that we received the invite and now we're trying to do what you asked rather than waiting until the phone's already ringing. We'll let you know, hey, we're trying, so that if it never rings, you don't get no response from us at all. Of course, once the phone call gets answered, it maps nicely. A 200 OK is basically you saying, I was able to complete what you wanted, i.e. answer the phone call. And then that turns into an answer message in the SS7 architecture and their signaling language. And then what you'll notice is there's an acknowledgement in SIP that goes back that's saying like, hey, they acknowledge that you told them the call's answered. This is just to make sure and maintain that both parties are seeing the same thing and have the same call status. Last but certainly not least, there's this idea of when the call gets hung up in SS7, they send a release, and then in response to that, you would send back a release complete. That's that REL and RLC. And then in the SIP world, we use a buy, which makes perfect sense to me, and response again 200 OK, acknowledging not just that we got what you wanted to do, but that we successfully hung up the call on our end as well. And so again, I don't expect anyone to be a SIP flow master, and I don't know how much time anyone spent here in SIP signaling. There is a ton of data that goes into each one of these messages that gets sent back and forth. There's a lot more in the payload other than just the word invite or trying. But I think this is a nice way to kind of understand like all of the communications back and forth just in establishing the call. Tons more can happen once the call is connected. We can transfer calls, et cetera, and all of that happens within the signaling. And you can imagine that this is in many ways the primary role of your carrier is to establish this SIP that you're talking to them with and make sure that they're translating it back and getting it to the PSTN in the proper format. With that said, I kind of want to take a step back and say, hey, what if we look at, the call flow overall? So we're making calls over the internet, not just the SIP signaling in detail, but like what's the whole call flow look like? Well, one thing that I learned early on is that there's actually two separate call paths. There's the signaling and the media. And this is something that I find very interesting. And I think in the next slide, I'll kind of help display that visually. But what's interesting about this is for those of us who have ever worked with like PRIs or traditional phone calls, right? A traditional phone call path is 64 kilobits, but the actual audio, the media is really only 56, and the signaling is 8. So it's 56 kilobits and 8 kilobits, and they run over the same copper twisted pair, the same old school POTS line, plain old telephone service. And so you're running those over dedicated infrastructure, right? Old school PSTN is dedicated infrastructure. And so it's really easy to run both the signaling and the media over that same copper twisted pair. In the case of a PRI, you'd have 23, call it 56 kilobit paths, and then the last one is dedicated to the signaling for all of those paths. But on the internet, we have this separate type of infrastructure. It's not dedicated, it's actually shared, right? We're all leveraging the same roadways, the same bandwidth, and it's just dynamically shifting to who's using it at the current moment. And so what you find is that because of the way things get routed over the internet, the signaling and the media can take totally different paths, and they can involve more or less parties, i.e. not everyone needs to be included on the media, even though everyone needs to be included on the signaling. Of course, the internet has its own inherent problems, we'll call it. There's some security concerns that don't exist in the PSTN since it's dedicated infrastructure. No one else is actually going to be riding that plain old telephone service line, so you don't have to worry about anyone like inspecting your packets. And then, of course, there's the issue of quality, right? If it's this shared infrastructure, or as one of my first teachers used to tell me, if the internet is going to be full of cat memes, you are going to be overloaded with cat memes before you connect your call. Or in the modern world, Netflix will win. They will chew up more bandwidth and cause more latency and lag than you want to deal with on your calls. So kind of looking at this call flow is a nice way to understand more about what you're really relying on your carrier for. And so, again, this is an oversimplified call flow here, but just to kind of walk through what it looks like. Let's say you have a phone system, a PBX, as is often referred to, and you want to connect to your VoIP provider. You would initiate that initial invite. That's the signaling you're sending to them. Your VoIP provider may not have access to a carrier. They may be using some aggregator that gives them access to as many phone call paths as possible, and so they would in turn pass that message on to their aggregator. The aggregator would hopefully have a direct relationship with the carrier so that there aren't too many middlemen here. They would in turn connect to a carrier, and the carrier would in turn connect to the PSTN. Now notice this dotted line represents signaling. I have yet to show the media, and that's because until the phone call actually connects, there's no media. The ringing that you hear on your phone is actually produced by your phone. It is not produced like the audio over the call. And so once that call is answered, you establish media. But you'll notice here that the media may not touch the VoIP provider or the aggregator, but it obviously needs to touch the carrier who's going to take it to the PSTN. And so what you find is that last link from carrier to the PSTN, which is hopefully an actual PSTN interconnect, the path for the media and the signaling run along the same physical infrastructure. But for the rest of the call, you'll notice that that's not necessarily the case. And you might naturally be thinking, well, why wouldn't the provider and the aggregator want the media? Well, for starters, it's a lot more work to do. So that's where all the transcoding happens. So if there's codec negotiations, or if one side of the call, like on the PSTN, is using one type of codec and your end user and the PBX wants to use a separate one, it's the media server, it's that media anchor point that's responsible for transcoding and handling that conversion. that's very CPU intensive, especially if you're comparing it to simple signaling. Additionally, there's this question of what value add would you get if your VoIP provider was in the media path? Well, potentially you could actually have some issues. So if you've ever heard the term like media bypass or direct media, it means that, hey, the person you're working with is stepping out of the media path. They're basically saying like, hey, rather than send me the media and then have me send the media on to someone else, I'll just give you the IP address of where you should send the media to. The nice thing about this is that if your provider doesn't have a network or some way to actually establish calls over a private infrastructure with a quality of service sort of guarantee, this at least removes them from being a point of failure in the media per se, and you can instead send it directly to the IP address. However, it doesn't address the fact that all of these links are still running over the public internet. And so basically what your provider is doing is they're saying, I don't have a solution for the public internet. So even though signaling might have some latency that if it has to come to me and then go to the aggregator, I need to have that, and a little latency in your signaling won't really impact your phone call, won't impact the call quality of the audio. But since I don't have a solution for the media, and since it's expensive from an infrastructure overhead cost to handle that processing, you might as well send it directly to the carrier. I like to use the analogy, imagine if you went to the post office, imagine if you were still using snail mail, and you went to the post office, and instead of giving them an address, you gave them a name, and you hand them a name, and they handed you back an address. So, hey, I want to send a package to Elisa. So I go in there and I use Elisa's name, and they say, great, here's Elisa's address. And instead of shipping it themselves, they said, great, you can now go drive this to Elisa over the public roadways, and we're going to bill you based on how long it takes you to send your call, to send your package, to drive your package to Elisa's location, which I find somewhat comical, but it really is what's happening here. It's, hey, the signaling, they're basically charging you for establishing the location and telling you where this phone call needs to go, but you're using your own internet service provider to actually send the media, which is something interesting and kind of highlights the dilemma of voice over IP, i.e., there are some concerns with using the internet. But of course, in the end, everything does touch the PSTN, right? In the end, the goal is for your carrier primarily to make sure they get you here in a reliable, secure, and quality-driven manner, something that can be consistent from a performance perspective. But let's be real, there's a lot more that happens in your carrier, right? It's not just, hey, I need these calls to connect. You need to do other things. And so what we like to call direct control is this concept of, hey, what else does a carrier have responsibility for providing? And as a carrier, you have direct control over it versus a reseller, an aggregator, a provider, or someone that uses an intermediary. They're not really in direct control. They might be able to ask for things or request changes, but the direct control belongs to the carrier. And to kind of be more direct, what sort of direct control? Well, for starters, if you remove middlemen in any environment, and this is not telecom specific, but in any world, whether it's direct to source procurement of mattresses, you start to see immediate benefits. So the first benefit, like quality, right? If you're getting it direct from the source, there's a lot less places things can go wrong, get damaged in the shipping of a package, or in this case, in the shipping of phone calls over the internet. Of course, if you remove intermediaries, remove middlemen, the idea would be that you'd be removing points of failure, and therefore, you should have a much higher reliability in the service you're delivering. So in this case, right, in that diagram we just kind of looked at, it would be like if there's no VoIP provider and there's no aggregator and you're going directly to the carrier, that's 2 less places where things can go wrong. And then last but certainly not least, and as a business, as an entrepreneur hat, you're thinking, hey, there should be some pricing benefits, and absolutely there are. And in the end, what you're paying these resellers, these aggregators, these middlemen for is marking up the dial tone they're purchasing from someone else. And if they're not actually carrying the media, they're really just marking you up to make some money off of traffic that they're not necessarily providing any significant value add to, possibly, depending on if you're using them for something else. And so hopefully Those are some natural things that come to mind, some obvious or immediate benefits from no middleman, but there are some other things that maybe aren't as clear. And so I like this concept of self-service and automation. I think it's becoming more and more popular. I know 2600 Hertz, I was at KazooCon, there's a lot of self-service and automation on the side of provisioning handsets. Well, this same concept works from the carrier side, right? If your communications platform, the PBX, is responsible for provisioning handsets, the carrier is responsible for things like provisioning numbers or provisioning the SIP trunk, that connectivity back to the PSTN, and a number of other things. And the idea here is really like, if you're not the carrier, it's going to be really hard to drive self-service and automation to provide an API for your customers, some communications platform, to automatically allow for searching and provisioning of numbers. There are certain, call it duct tape or workarounds. Like, for example, you could house your own inventory, right? Buy 10,000 phone numbers from your carrier so that your API allows people to search and provision those numbers. But again, what you're really doing here is pigeonholing yourself. You have to guess what numbers your customers want. It really doesn't get at the true solution. Of course, you could say, hey, my carrier has an API. So as an aggregator, I'll tie into their API and provide an API to my customers. But now we're kind of in another workflow where there's a point of failure and you're also going to have multiple APIs talking to each other. Why wouldn't you just want to talk to the original API to do the searching and provisioning? Or if the carrier's API allows for explicit number search, but your VoIP provider doesn't, their API only allows for random provisioning or inexplicit number search and provision, you're limited again. And so there are some clear benefits around self-service and automation that you really can't get to unless you get to the source itself. And I think the obvious ones we talked about around provisioning numbers and trunks are pretty nice, but I think one that resonates really nicely with everybody is porting. And if you haven't had a poor porting experience, I would argue it's because you've never tried porting before. Porting can be a nightmare. It is the necessary evil of the industry we all chose to go into. You can't get their business without getting their numbers, and you can't do anything worse than have to deal with porting. That said, there's a reason why porting is so bad, and the number one reason is because people don't realize that if you submit a port to McLean's hosted PBX company, what you don't realize is that McLean's hosted PBX can't actually submit the port request. There are only two parties involved in the port request. There's the losing carrier and the winning carrier. And the winning carrier is the actual carrier, the one that has that regulatory authority and the one that has that direct numbering resource. And so what ends up happening is you end up with like 5, sometimes even more middlemen that are just relaying the same message. So the winning carrier has to, or in this case, McLean's hosted PBX, has to take your port request, reformat it to submit it to my provider, which may be an aggregator, who in turn reformats it and submits it to their carrier. So maybe they eventually get to like a level 3. Level 3 then tends and submits that to, let's say, AT&T, the losing carrier. And they're the ones who actually discuss authorizing, rejecting, accepting, etc. of the port request. If it gets rejected, not only are there multiple days that AT&T or the losing service provider has to respond to that request, there's also the problem that if they respond to level 3, who then in return sends a message to their customer, your aggregator, there's like potential for 4 days of delay to simply tell you, hey, there's a mismatch on the authorized username that you're using, which can be a huge pain. So Telnyx, since we're not an actual carrier, we spent a lot of time working on automated portability, and this is something that I feel like can have huge implications on the efficiency with which you close deals, the way that you're able to better support your customers that grow, right, that bring on a new office, or if you support like a managed service provider, if your platform in turn supports other B2B platforms. There's a lot that can be gained from automating this process. And doing so requires that you have an actual carrier. And I mentioned earlier some of those systems that you can get access to, like NPAC or internetworking to get CSRs. You can imagine with like Telnyx per se, if you submit a support request, rather than us shoot that over to level 3, we can automatically pull the customer service record and validate your information prior to actually submitting the port request. So instead of giving level 3 or the losing carrier 48 hours to get back to us and tell us whether or not the information matches. We'll validate it and tell you right away if there's a potential mismatch and give you a chance to correct it. So when we submit it to them, there's not just wasted time where we're waiting to hear back from either side. And so hopefully this is like a pretty concrete opportunity for you to see where carrier status and self-service and automation can actually drive your own revenue. It can shorten your sales cycles and certainly reduce overhead from a support perspective, because nobody wants to deal with this stuff. Of course, there's another interesting use case that I think can be helpful to look at. And so I'm pulling back up that call flow we were looking at before, and let's talk about troubleshooting, right? We've all had the wonderful pleasure of a customer calling us and telling us that something's not working. And so the first thing you do is like, okay, let's take a look. So let's say as the VoIP provider, you have a customer PBX and bam, you have an issue. Okay, great. There's something going wrong between the PBX and you. Well, you don't know where in this chain the issue is. So like, for example, maybe the issue is right here between you and your customer. This is probably the best news. It means you can solve the problem. Hopefully quick and easy. However, what if the issue is between the aggregator and the carrier? You have no insight into this. The aggregator's handling all of the signaling from here, and in turn communicating signaling here. They're not exposing this information to you, so you're kind of SOL. You're in a situation where you have no insight into this leg of the call, and you have no mechanism available other than to maybe open a ticket with your aggregator or with your provider, with whomever it is. And so you can immediately see, okay, this could be a pretty big problem. And so when we talk about why or how a carrier can further empower you, well, they can own what they're supposed to own, right? The carrier is supposed to be responsible for primarily getting you to the PSTN. And if they're using a ton of intermediaries or middlemen, you are leaving yourself vulnerable to points of failure that you cannot test. So in a perfect world, right, we would remove everybody here in the middle, we'd connect directly to the carrier, and in turn, we would hopefully have a much more reliable experience. But most importantly, in the event that something goes wrong, you will be in a situation in which you can clearly see who it is that's responsible for solving this gap, i.e. it's either between you and the PBX as the carrier, or it's between you and the PSTN, and you can solve for that. You have access to both. I feel like there's a number of times you probably called your provider and they're like, we made a routing change. It's not working. And you're like, okay, well, what happened? Where was the issue? Do you know what the problem was? And it's usually the case, like, we don't know. We just had to pick something else. We had to pick another carrier, another aggregator to use. Usually means there's multiple middlemen in the way. And we could dive into that later if we want to talk about that in more detail. Now, the last leg here is you still need to connect to your carrier, right? So what I was just showing you there was the carrier is connected to the PSTN, and you want to make sure that from your carrier to the PSTN, from your provider to the PSTN, from your service provider, whatever you want to call them, that there are as few, hopefully zero middlemen, 0 additional points of failure in that call flow. But what we really haven't talked about is the last part of the equation. That is you connecting to your carrier. And one of the things that's become ever prevalent in this modern world of communications is, oh my God, what ways can you not connect to your provider? Is it some sort of WebRTC client that runs within your Salesforce click-to-call solution? Is it a hosted phone system that lives in a multi-tenant environment and is distributed across the globe? Is it just a mobile application? Is it a more traditional contact center? With all of these different ways to communicate with your provider that you can leverage the internet to do so, there is probably a concern, or at least there should be a thought about what about the leg between me and my provider, not just everything that happens after that. Well, it's a great question to ask. And the real reason we're asking that question is because the internet was not designed for real-time communications. I don't know how much everyone has spent in the IP world and looking at the protocol of the internet, but the major protocol that routes traffic on the internet is called BGP, Border Gateway Protocol. It's actually often referred to as the two napkin protocol because these two gentlemen, I think it's Kirk Lauweed and was it Yaakov Rector? You might have to double check me on that. They actually like wrote this protocol at some conference while they were grabbing lunch on the back of a couple napkins. And so although it was brilliantly simple, it has some inherent risks to it. To give you an example of the risks of the internet and some of the, call it, non-optimal settings, in 2010, if those of you remember, around, I think it was April, China was able to route all of 15% of the entire internet traffic through all of their servers for 18 minutes. It was through this thing called IP hijacking. I don't want to get into the details, but the long and the short of it is there's a lot of vulnerabilities to how traffic gets routed over the internet. And so you ought to consider, hey, how am I connecting to my carrier? Is this a reliable mechanism as far as maintaining this connection? Is it a quality connection, one that we can count on to establish reasonable call quality across not just a particular customer, but across various locations of various customers around the US, your region, the world, etc. And so there are basically three ways that I like to think of connecting to a carrier. So in a traditional sense, right, if you're not physically plugging in, and you can certainly physically plug in, you can do a cross connect, there's this idea of logical connections. And the reason why logical connections are great is it basically is saying, hey, myself and my provider already have infrastructure in places that meet. What we want to do is carve out logically a private link so that way we can establish private connectivity without having to do a physical build out. Telnyx has something that we call virtual cross connect that allows us to do this into your virtual private cloud. So you can imagine you're in AWS, Telnyx has already got fiber infrastructure in AWS, and you can carve out bandwidth on there and privatize that link so that we go directly into your VPC without touching the public internet and avoid some of the risks of the public internet, higher security, way more reliable, and potentially a much higher quality conversation that you're having. Now, the second piece in the middle is this idea of a global backbone. And the reason I mention this is if you remember in that call flow, right, everyone's outside of the media path. Well, why? Because most of these voice over IP providers don't actually have their own autonomous system, their own actual network, their own backbone. And so by having a global backbone, what can happen here is when you connect to your carrier, they can actually then pull the rest of the call on their own backbone. This is like often referred to as quality of service if you're using an MPLS network with your provider. But in my sense, what I like to think of it is as, do they have a backbone? Do they have some sort of private network that their calls ride? Or am I simply hitting their server and then they're in turn sending it back over the public internet to their carrier or to the PSTN? And lastly, there's this idea of IP interconnects. And this goes back to kind of, if you understand how border gateway protocol works, you will probably understand that the same IP address, the same address, location you're trying to get to, does not mean you're going to take the same path every time. And so if two packets leave the network at the same time with the same address and the same IP address they're going to, they still might take totally different various routes all over the place. And a lot of this is determined by what sort of IP interconnect, sort of peering your provider has in place. So for example, if you peer directly with AT&T and Verizon, then when AT&T and Verizon receive a packet that's destined for an IP address that you own, they will send it directly to the link that you have with them. If you're not peering directly with them, they're going to send it to like a default route. They're just going to send it onward until we find a router or find a network that is aware of your location. And so understanding your carrier, your voice over IP provider as an actual autonomous system, as an actual ISP is important to understanding what they're capable of doing to address the problem that is the internet. So in many cases, like there are concepts that you can only use if you are an ISP, if you have a backbone. So like, for example, a concept that Telnyx really likes and leverages this idea of an Anycast IP. If you're not familiar with it, imagine if you had 5 home locations and you wanted to use the same address, the same mailbox street location for all of them so that you could give everybody one address, and when they sent mail to it, it would automatically go to the nearest house to them. If you have a house on the West Coast, a house on the East Coast, and a house in the Midwest, someone who's sending you a package from the Midwest will automatically go to the Midwest. Someone in the West Coast will automatically go to the West Coast. And this is all done using the same 123 Main Street address. That's the same way that an Anycast IP works. Hey, here is the Telnyx IP. If you hit this IP address and you route to it, if you route to it from somewhere on the East Coast, it'll actually route to our East Coast point of presence. Similarly, on the West Coast to our West Coast point of presence. And these things are really only possible. The only way to really address the issues of the public internet is to really be an ISP, is to have this established peering session. In other words, there's a last mile issue, right? Everyone's got their local service provider, and if they're using Comcast business class cable for their internet or some other cable provider, you're really relying on Comcast's ability to route that packet, that voice call to the IP address given. So if you aren't, as a carrier, putting yourself in a position to best close the gap of the last mile, you're really not empowering your communications providers to do their job, which is focus on their customer experience, focus on the tooling that their customers can use. And so kind of to bring it back full circle, so like this is the Telnyx network. And I don't really know if this is super valuable, but it's a screen that I can sit on while I kind of group everything back together. The real kind of goal, and hopefully the understanding that comes out of this conversation, is that there are a lot of links in the chain of placing a phone call. And that alone should be a reason why you view your carrier with some scrutiny and take a look to see, hey, are they really a carrier? How many links am I not seeing? How much is being hidden from me? And how much of that is affecting me today? And how much could potentially affect me in the event of an outage, of an issue, et cetera? And then secondly is to be reminded that it's not just that their primary responsibility is sending and receiving phone calls on your behalf. There are a number of other applications like porting, like provisioning, like troubleshooting that really rely on the source, the actual carrier connecting the call, to perform that function, to provide visibility into that issue. And so as a communications platform provider, as a solution provider of really any sorts, you really need to take a look at the carrier and be reminded that in many ways, you're only as good as the weakest link in your chain. You're only as strong as the weakest point in your call flow. And so whatever you can do to get to direct source will hopefully provide you with an opportunity to empower your own customers with things like self-service and portability, et cetera, and also provide some reliability and transparency into the relationship you have with your provider. So hopefully we were able to accomplish some of that. I do see that a couple questions got asked. I didn't see any hands pop up in the middle of the call. So at this point, Elisa, I'd like to hand it back to you. Thank everybody for the time, and maybe we can walk through some of the questions that have been proposed thus far.
Great. Yes, we do have a few questions for you. The first one being, going back to troubleshooting, I often hear, quote, "We changed the routing and things are now working," end quote, from my provider. What does that actually mean?
That's a great question. That's a great question. Yeah, so I kind of touched on that a little bit. So let me circle back here, if I can, to this. Okay, so if we go to, let's say, for example, there is an issue here. What's usually happening is, if you haven't heard of this concept of least cost routing, the idea is, hey, I don't have necessarily direct access to all of AT&T's routes, PSTN. I don't have direct access to Verizon, CenturyLink, Level 3, et cetera. And so what you do is you would leverage an aggregator who either has multiple connections or they themselves leverage other aggregators. And what will happen is, in this least cost routing mechanism, it's going to say like, hey, I can send this call to provider 1, provider 2, or provider 3. I'm going to determine which provider to use based on who provides me with the least cost route. What ends up happening is you end up routing calls to less reliable providers. And what when you call your service provider and say, hey, there's an issue, and they say we changed the route, what that usually means is they pulled someone out of their LCR. So provider 1 was the cheapest, but they kept having issues, so they've been removed, and now all of the calls go to provider 2 or 3. It usually means that the service provider you're working with doesn't actually have access to the PSTN directly. It is possible that sometimes, something goes wrong at a local tandem level, and there was an actual PSTN operator that was having an issue with a particular route. But it most often means that what they're doing is they're taking one of their resellers out of route and using another reseller. That's actually a great question that pops up all the time. And if you haven't had someone tell that to you, I'm shocked, because I feel like that's usually the given explanation you get. So thank you. That was a great question.
Great, thank you for that. And our next question is, can you explain the last mile problem again? I have a cross connect with my provider today, and I'm trying to understand what else could be done to improve quality.
Yeah, great. So let's go back. Here, perfect. Okay, so in this case, right, let's say you do have a physical cross connect in place between you and your VoIP provider. If your VoIP provider doesn't have a physical cross connect to the PSTN, 1, they may not even be carrying your media. That is, they might take this same route here and say, even if this right here is a physical link, or I think I can use the little pointer tool. Even if there is a link right here, if there's no link anywhere over here that's physical cross connect status, there's no benefit to them carrying it, so they might actually ask you to send your media over the public internet anyway. The second thing is what people don't necessarily think through is, hey, this might be you, some hosted communications platform provider, and you have a link with your provider, but your end users don't. So some end user out here is coming over you over the public internet, and you have an option. Are you going to carry the media, or do you want this line, instead of it starting here, do we want it to start up here and go all the way to the carrier itself? The question is usually, do you need to have the media? That is, are you doing voicemail? And a lot of newer phone systems will actually intentionally remove themselves from the media until someone is going to voicemail. In other words, they'll use media bypass everywhere they can except for where they absolutely need to be in the media. So then what happens is you now have a situation in which you might have a cross connect, but it's not actually benefiting you unless that person, that provider, is taking you directly to the PSTN. And so when I say closing the gap of the last mile, I'm saying, well, what if your provider, your carrier, had a point of presence here, had a point of presence here, had a point of presence here, and so when your customer out here wants to connect and you tell them, hey, you need to connect to my carrier's IP, they can leverage like Telnyx's Anycast IP, for example, and this right here will be the entire chain from virtual customer up here that's not on the screen down to here. They will be the actual link. This will be the total link that goes over the public internet, and the rest of this would ride your carrier backbone. And so that's kind of the last mile issue that's the reason why Telnyx built a global backbone. It's so that we can leverage that. It also is worth noting, like, what if you have customers that are in different geographies, or what if you want to go global? Do you now need to deploy your MPLS network globally so that you can bring it back over that cross connect? Or if your provider is helping to solve that last mile gap to an extent as well, you can leverage their infrastructure elsewhere. I'm not sure if that truly explained the issue, but hopefully that provided some clarity onto what I was referring to.
Great, and those are all the questions that we had. So everyone, thank you so much for joining us today, and a very special thank you to McLean for the awesome presentation. If you, again, like we said earlier, have any topics or people you'd like to hear from, send us an email at marketing@2600hc.com, and we'll see what we can do. All right, thanks everyone. Have a great day.